Okay guys, here we go. Starting a new unit right now, 3.1. You have your notes little sheet in front of you, and then you have a big blank page. So we're going to fill that page up with some notes and some examples. Today we're starting to talk about algebra. And algebra is just arithmetic using variables. What does that mean? Well, arithmetic uses the operations addition, subtraction, multiplication, division, etc. using values 1, 2, 3, 4, -5, -10, etc. And we can use all those same operations using variables. A variable is just an unknown number, usually represented by a letter. We'll get into those notes a little bit later. But right off the bat, we're going to talk about, because today we're using concrete material. So you have in front of you all of your unit blocks and your x bars, and you have a few x squared areas. And we're going to introduce those right now so that we can start to use them. So the first thing that you have there is a little box. And you can draw a little box and color it in. This is a unit tile. A unit tile. It just represents the number 1. Represents the number, or the value. Let's say the value represents the value of 1.
Can you give an example of one you'd ever use?
For example, well, we're going to use them to help us learn algebra. But if you had 2 of these, you would just have the value of the number 2. Yeah, not so difficult, eh? If you had 1 here and you added it to 3 here, how many would you have?
You had 4, but why don't you just...
No, but Mr. V, if those 2 boxes are together, isn't that times?
1 times 1 is 4.
There's 1 box here, and there's 3 boxes here. We added them together. We've got 4. Good. The next little physical block that we're going to be using is, well, I'll write a little note first. Here we go. Let's write a little note on, we said that algebra is just arithmetic using variables. So what's a variable? This is a quantity. That's just like, in brackets you can write an amount, a quantity or a value. That's, yeah, a quantity amount, whose value can change. So you don't know what it is. So if you're talking about the value x, well, x could be 1, x could be 2, x could be -7.5. You don't know what it is. That's what makes it a variable. This is usually represented by a letter. So, when we're working with our algebra tiles, we are going to have a tile that looks like this. It's like a bar. And you can see, because it's already right in front of you, that this is called the X tile. And it represents an unknown value. It represents an unknown value.
Are you saying, so when we're doing math, we actually have to put a rectangle around our x?
Oh, yeah.
No.
So what's the point of learning that with all these tiles?
More work.
It's a visual representation of how numbers work. It's going to help you understand how to do algebra. So, right here, what do we have?
2 x tiles.
So here we have 2 x tiles, so that's the same as 2x.
Sounds like textiles.
Okay? 2x. And we could do, we could draw 4 of them and have 4x, or 6 of them and have 6x, and you could even have negative x bars.
It's X2.
We'll get to that on a different day.
Negative sign in front of the box.
Put a little negative sign, not in front of whatever. It doesn't really matter. With algebra tiles, you'd use different colors. For instance, I have orange for positive numbers, but I also have blue for negative numbers. But you only have one color, because today we're doing all positive numbers.
Because today is going to be a positive day.
All right. So how would we represent? Let's say I'm gonna clear my board, and I'm just gonna leave a unit block up there and an X tile up there. And you have a couple questions here. How would we represent, using just unit tiles or X tiles, how would we represent, let's say, the amount 6 kilometers?
6 bars.
6 bars?
No.
6 dots.
6 unit
Squares.
tiles, right?
Okay.
6 unit tiles. So go ahead and
We
draw
have to write these down on our
6
notes.
unit tiles. Yep.
Can we put them beside? These are a lot of note taking, or no?
Yeah.
Hey, Mr. Me,
How would you represent an unknown distance?
With the bars.
How many bars?
We don't know.
Because it's unknown.
One.
Oh.
1 bar. It's a single unknown distance.
Are you a games guy, Mr. Me?
Okay? Sam, you got an infraction.
What?
C. How would we do an unknown distance and back? An unknown distance and back.
2.
To what?
2 of the bars.
2 of the bars. The unknown distance is x. We don't know how long it is. Doesn't matter where you're going. You don't know how long it is. But if you go that same distance exactly twice, so there and back, you have 2 x's. Now, does this work if I were to say, okay, Olivia drove to Maddie's house and Jacob drove to Emily's house? Is that 2x? No, because those distances are not the exact same. It's not a repeated factor. One might be represented by x, the other distance might be represented by y. So you wouldn't have 2x, you'd have x and y.
Then how would you
Okay.
show? You can't show that. In the
I should have drawn this out instead of writing it, but there you go. However you want to do it. And the last one is a little bit trickier. 3 kilometers plus an unknown distance.
3 and then 1 of
Try to just do it without calling it out. An unknown distance plus 3 kilometers. So we've got our unknown distance, and we're adding 3 units. Now, is it possible that this unknown distance is actually less than a kilometer? It's definitely possible. Okay? So don't assume that x is always worth more than a unit. Just because it's bigger does not mean that it's for sure worth more. Okay? It's just what we use when it's unknown. It might be 1. It might end up being 1. We don't know.
Should we
Okay?
do 3 big rectangles instead of doing 1 plus 3 small ones? Or no?
This bar represents the unknown value, of which there's 1.
Oh, okay, yeah.
And these guys represent units,
Oh,
and there's
yeah.
3 known units.
And like a question like that, what would you do first? Like, does it not matter?
Addition is commutative, which means you can swap them around and it makes no difference whatsoever. But you're right, it says 3 plus x. And we could say that algebraically as well. We could say 3 plus x, or we could say x plus 3.
Oh,
Okay? Well, if we have units and we have x's, that's just an unknown value as well, which we've used to represent distance as an example. How would we do something like area? How would we represent area?
Isn't that like where you have the squares inside a box?
So we have a bigger box essentially, right? Yeah. So
Graph inside
Nice. So we can use x squared tiles to represent area. So you have x squared tiles, and what's cool about the x squared tiles is they have side length x, right? And that makes sense because area is length times width, right? So since area is length times width, and the length of each side of a square is the same as the width of each side of the square, and since an r square in particular, the length of each side is just x, we have x times x, which is x squared. If you're not sure about that rule, we learn this next lesson, so just take it as it is for
I
now.
don't get the squares. Why? I understand the formula, but I don't get the squares.
That's okay. We don't need to totally understand how this works yet. We talk more about it next lesson. But if you have, like, for instance, if the length of your backyard was a square and each side was 4, this side is 4, and this side is 4, then how many little boxes would it actually be? Maybe 16 little boxes. 4 units times 4 units.
I don't understand where the 16 skinny x's come in.
These, I'm just showing that this side length is x, and this side length is x. Yeah, that's the only goal there. And x times x is x squared. X times x is x squared.
So two of them equal x.
Be careful, don't mix up addition and subtraction. If I had this, x plus x is just 2x. Okay?
Yeah.
But if I wanted to get the area of something, area is length times width,
Yeah.
x times x, which is x squared. Let's carry on for a sec. Okay, so there's a few different ways to represent area. We can, if we don't know the length that we're talking about, we use x's. But sometimes you do know, like the example that we did there, we said it was, your backyard was 4 by 4. Or maybe you have a little pond and it's 2 by 2. That doesn't make any sense. 2 by 2 what? I don't know. But anyway, if you had a square that was measured in units, 2 by 2, okay, then we're still talking about square units. We have 4 square units. It's the same as 2 squared. Okay, or we could have a square that was 3 units by 3 units. What is the area of this block?
3 by 3, 9.
3 by 3, which is 9, which is 3 squared. Okay? If we don't know the length of each side, then we represent area by using x times x, which is x squared. Okay? Is it possible that this area x squared is less than this area?
Yes.
Yeah, it's entirely possible. It might be way bigger, it might be way smaller, it might be smaller than this one. It might even be smaller than just 1 unit. This is 1 squared, which is 1. Yeah.
What if you only know one side? What if it's 4 and x?
If it's a perfect square, which is what we're talking about,
What
if you know one side, you know all the sides.
if it's not?
If it's a rectangle, then it doesn't apply to what we're doing here. Yeah, but we will get to that as well in our algebra using algebra tiles. You can build rectangles and find out the
Wait,
area.
so those squares aren't
Don't do this yet.
So these squares, this is 1 unit, 1 unit, 1 unit, 1 unit, 1 unit, 1 unit, yep. But this one is not. We don't know what this one is.
Okay.
It's x squared. Jaden?
Is this where we start using pi and stuff?
That will come into play, yeah, but pi is not a variable because pi never changes. Pi is just an irrational number. So you don't write 3.14 yada 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 yada, you just write the symbol pi. Yes.
I don't get this.
That's okay. We're going to work into it slowly. This is just a very brief
Like,
introduction.
The whole block thing, I don't get it. Like I know like how to do it with like the letters, just like 2x equals equals blah 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 or whatever. But this letter, like all the blocks, just they don't make sense.
Yep, that's okay. We'll work on it. Okay, so now we have three options. We have a unit, we have an x, and we have an x squared. Okay? And we're going to draw a box that is 16 square units. Now, which bars are we going to be using? Which tiles are we going to be using if we already know it's just 16 square units?
The little one.
We're just going to be using these guys. Okay? And we need 16 of them arranged into a perfect square. Do you know what the dimensions? 4 by 4. Okay, this is 4 squared. B. I'm going to skip B. Well, we'll do it. It's 25 square units. We'll do it orally. What would it be?
5 by 5.
5 by 5, which is 5 squared. So if we write the example down, 25 square units, let's just write it equals 5 squared. You don't need to draw that one. And we're going to move to C. Don't call this one out, but think about it. It's 3x squared. What would that be? Think about this. Is it going to make a perfect square if you put them all together? It's not. Okay, you have x squared, and how many of them do you have?
3.
You have 3 of them. So this looks like this. X squared, X squared, X squared. Okay.
Put them in kind of a box. Or
You can. They should always be arranged in kind of a rectangle-ish. Yeah. So you wouldn't do it like this. Okay. You'd probably leave it like this, just it's easier to see and read. But it doesn't really matter as long as you've represented 3x squared. We have 3 x squareds. D. 5x squared. Go ahead and draw 5x squared. Okay? Nothing too challenging there. It's really just x squared plus x squared plus x squared plus x squared plus x squared. 5x squareds. Yeah? Okay, we're going to start doing a couple of other examples that combine using each of these different tiles. So I'm going to clear my board. And you're kind of in a new little section here. It's just getting a little bit more challenging, but I guess we did A, B, C, D, so I'll just keep going on E. We're going to do x squared plus 2. Go ahead and draw that. Draw x squared plus 2. Okay, your example should look... Oh, sorry. And the next one, maybe I was reading ahead. 2x squared plus x. Now, whenever I'm adding regular numbers like 2 plus 4, I can just stick these together and say 6. And whenever I'm adding x's like 2x plus x, I can just say, oh, I have 3 x's here. Can I do the same here with 2x squared and x? No. Okay? These are different measurements. Okay? Yes, this has side length x and side length x, but the value is x squared. This value is only one factor of x. Right? So inside each of these boxes is like x times x. And here's x times x. But here, we just have x, and all these guys are getting added together. So you can't just group them together. You have 2x squareds, and you have 1x. Okay? That is going to be very... lots of people get tricked by that. somewhere along the line you're going to see 7x squared plus 4x minus 6, and you're going to say, oh, I know what that is. That's 11x minus 6. No, it's not. Okay? Good. Let's carry on. E, F, G.
It's not?
No, you cannot add, you can't group your x squareds and your x's. Okay? They're different. They're not the same. Okay? It's like adding basketballs and volleyballs. You wouldn't say, you know, you have 5 basketballs here and 4 volleyballs there. Okay, I have 9 basketballs. No, you don't. You have 5 basketballs and 4 volleyballs. They're different. Right? A, B, C, D, E, F, G.
Use units.
Yeah, in a second. X squared plus 3x plus 2. Go ahead and draw that using your algebra tiles. Hopefully, if you're following the same strategy over and over and over again, you're getting it right over and over and over again. So that should look like we got x squared, we've got 3 x's, and we have 2 units. And the last one here, 3x squared plus 5x plus 1.
What would you say that equals though? Like the 2x plus the 3x?
It's a really good question. What does this equal? It equals x squared plus 3x plus 2. You cannot reduce it any more or any less.
You're not solving for numbers.
Why can't you join the x's together to make
Well, that
a
is solving
big
because
one?
there's no numbers involved. You're not
You don't know
solving for
how
numbers,
long
you're
it is, so
solving
you don't
for
know if it makes a
Yeah.
square.
Yeah.
Okay. Did you draw this one?
No.
By the way, the reason we cut all those algebra squares is so that you could use them during this part of the activity, but I forgot to tell you that.
Nice.
So you could have been building these and then drawing them.
Are we ever going to use them again?
Yeah, maybe, if we remember. Okay, so here we have 3x squared. We're going to add that to 5x tiles, and we have 1 unit tile. And that's as reduced as that can possibly be.
So if you see a number that's
So, we
X,
have to reduce
Why don't you have to read the plus signs in?
Pardon?
Yeah, I write plus signs.
Like 3x, like in the things that when you draw it.
Sure, you could put a plus sign in between every single little
No, I
thing you
meant
do.
like in like the 3x and then plus, and then like the 5x, or 3x squared and then plus.
This is a visual representation of what this is. You have x squared plus x squared plus x squared plus x plus x plus x plus x plus x plus 1. And
you said you never knew the I thought you said you never knew X.
okay, what we just did, all of those little things that we talked about with our x squareds and our x's and our units are called algebraic expressions. Algebraic expressions. This is an algebraic expression is a mathematical phrase. I usually call it a sentence, a number sentence, a mathematical phrase or sentence made up of numbers and variables. Numbers and variables connected by addition and I guess we say or addition or subtraction. Algebraic expressions can be used to model real-world situations. So, for instance, let's take a hockey player. The hockey player you know that they average 2 points per game. So between goals and assists, they average 2 points per game, but you don't know how many games they played. 2 points per game, but you don't know how many games they played. 2 times X. That's how many points they got. And then as soon as you know how many games they played, let's say they played 15 games, you just sub that in for X, and then you know they have 30 points. Okay, so it's an unknown value, but it is still just a value. Okay, here's a couple of examples of algebraic expressions. And we've done a bunch already, and we've drawn them out, but here's, let's say, 2x plus 3. Okay, it's a mathematical sentence made up of numbers and variables connected by addition and subtraction. Now this 2 is also attached to this x by an operation. Remember, operations are addition, subtraction, multiplication, division. Do you know how 2 is glued to x? Multiplication. Okay? Say multiplication is the default operation of algebra. If there's nothing there and the values are just stuck together, it's multiplication. Okay? So we have 2 times x plus 3. Now this is called a term, and this is called a term, and they're stuck together by addition. Okay, we could come up with another one. We could say x squared minus 2x plus 7.
But wait, aren't you gonna solve 2x plus 3 because we're gonna be 5x?
No, not at all. These are x's, and these are units.
So
If
what
we
would it
drew
be?
it, it would look like this,
So
You'd have
everyone
2
has to do
x's.
this wrong.
No.
and 3
It's
ones.
like a whole new thing.
You do not add these together. They're not the same. That's what we just spent the last kind of 15-20 minutes discussing. They're not the same. Units cannot be added to x's. Okay? This is simplified. This is as simple as this expression is ever going to get.
You have to simplify it.
Okay? This is simplified. It's as simple as an expression is ever going to
If
get.
we find out what the two x is, then can we add them?
Yeah.
If you knew that x was 1, then you could say, okay, I have 2 of those plus 3. That's 2 plus 3, that's 5. Okay? But we use variables to represent situations where the value of x changes. So let's say you're going for a walk, okay? And you started 3 steps away from your house, and every second you're going to take 2 steps. Well, if you walk for 1 second, yeah, you're 5 steps away. But what if you walk for 23 seconds? Well, you can calculate that. If x equals 23, then how many steps have I taken? Well, I just sub 23 in for x, and I add those 3 that I'm away from my house already, and I end up with 46 plus 3.
So then it turns into dead mass if you know what x is.
Correct. If you know a value, then this is all just numbers strung together by your operations, addition, subtraction, division, multiplication. Then you can find the exact value. But algebra is used in situations where you don't know the exact value. Yeah? We're going to do examples. You'll get better at it. It's not a big deal that you're a little bit lost right now. Okay. Let's do... That's actually the end of this... that's the end of this little portion.